Good morning, everyone. My name is Dheeraj Nagarjuna Jagarlamudi, and this is Srija Edvalli. We are excited to present our project for Methods of Empirical Analysis course titled Mental Health Sentiment Analysis from Social Media using Machine Learning. Our work explores how machine learning and NLP can classify mental health statuses based on text data, offering a data driven approach to mental health diagnostics. Mental health is vital but often underdiagnosed due to stigma with digital communication. Text analysis offers a new approach for mental health assessment using a dataset of 53,000 statements labeled across seven mental health statuses. We applied machine learning and NLP to classify these statuses, addressing challenges in pre-processing, feature engineering, and ethical considerations. Setting the background, mental health research has evolved, moving from stigmatized views to data-driven solutions. Traditional methods like surveys are time consuming and lack scalability. With NLP and big data, we can analyze text from social media to gain insights. However, challenges like linguistic variability, contextual ambiguity, and ethical concerns required careful preprocessing and robust computational methods to deliver meaningful outcomes. Now, my teammate Srija would take over.
Well, coming to ethical framework, ethical concerns include privacy, data security, and the potential misuse of sensitive mental health data. The project ensures participant rights are protected through adherence to ethical principles like respect for autonomy and beneficence. Well, the dataset is pre-anonymized to ensure user privacy and prevent stigmatization. The project applies ethical principles to safeguard against exposing sensitive information while presenting results in an aggregated, non harmful format. Ethical principle guided pre processing, such as removing identity related data like usernames and timestamps, model evaluation avoided biases against sensitive classes like depression and suicidal. Promoting fairness and societal benefits. The next will be continued by Dheeraj.
Well, thank you, Srija. As the empirical analyst, I implemented machine learning models to classify mental health statuses. Random forest was the optimal model, excelling in high dimensional data. Feature engineering, such as the number of characters and sentences, improved performance. Evaluation metrics, including precision and F1 scores, validated the approach, achieving 95% precision for anxiety. Word clouds highlighted key terms, demonstrating the model's ability to capture linguistic nuances. Srija, would you take over with the
Yes.
methodology critic perspective?
Yeah, as a
Thank you.
methodology critic, my role was to evaluate the fairness, accountability, and interpretability of the methods used in this project. While Random Forest is a state of the art algorithm known for its predictive power, I emphasize the importance of addressing class disparities, ensuring interpretability, and adhering to ethical standards. And random forest, like many ensemble methods, is often criticized for being a black box, making it difficult to explain its predictions to stakeholders, especially in sensitive areas like mental health. And ethical issues were another critical area of focus. All data was anonymized, removing any personally identifiable information such as usernames or timestamps. By ensuring that the findings were presented as knowledge aids rather than diagnostic tools, we minimized risks of misuse and promoted trust in the results. This approach reflects the importance of responsibility and explainability in computational methods for mental health. The next will be continued by Dheeraj.
Uh, uh, Now, let us go through the methodology and implementation part of the project. Let me share the code which I've used in the project. Uh, well, our project began with a dataset of 53,043 statements that were taken from a publicly available database of in the data is categorized into seven mental health statuses. The pre-processing steps included removing missing values, cleaning unwanted patterns like such as URLs and special characters, and standardizing the text to lowercase. We faced a lot of missing values and unbalanced data, so we had to change a lot of, do a lot of pre-processing steps. And then additionally, we engineered features like a number of characters, sentences to enrich the dataset's structure. All these plots which you see are related to the distribution of data, and you can see how the data is being distributed in various plots and clusters. And this is the word cloud we were talking about earlier. This shows the dominating words of each category. And then we have used TF-IDF vectorization for feature extraction and transform textual data into numerical representations and balance the dataset using SMOTE technique to address class imbalances. We have split the data into training and testing sets and implemented machine learning models, including naive Bayes, logistic regression, decision tree, and random forest models. Each model was evaluated using precision, recall, F1 score, and confusion matrices. Random forest emerged as the most effective, achieving an overall of 75%, while logistic regression maintained the stability across categories. Let me show you the confusion matrix of each model. This is the, I'm sorry, this is naive Bayes, logistic regression, decision tree, and then finally random forest. Uh, Logistic regression maintain stability across broader categories. Uh, Statistical tests like t-test, SANOVA, and 2-key HSD helped validate our findings, ensuring the rigor of our analysis. uh, Getting into the results part of the project, Random Forest achieved the best performance with 95% precision with for anxiety and 97% for personality disorder. Logistic regression provided stability but struggled with advanced categories like depression. Visualizations, including confusion matrices and performance metrics, showcased Random Forest's superior classification ability. These results highlight the feasibility of machine learning in mental health diagnosis, particularly for complex text data sets. Uh, Srija, would you like to take
Yeah.
over?
Coming to evaluation and critic, one major concern I raised was the class imbalance, especially for the suicidal category, which posed a risk of bias in predictions. To address this, weighing was applied during model training, which improved the performance of models like random forest, ensuring balanced predictions across all categories. And I also recommended incorporating evaluation metrics like Cohen's kappa to assess inter-rater agreement and improve the reliability of classification outcomes. This would provide a more accurate understanding of the model's performance. For future work, I suggested exploring semantic relations by applying word embeddings like word to vec or glove to capture deeper context in text data. Additionally, testing the models on diverse datasets would help increase the reliability and robustness of the conclusions. Coming to rebuttal, I raised an argument saying the dataset may not simulate real life situations comprehensively as it could omit statements influenced by gender, language, or cultural backgrounds, leading to biases.
I think the data was pre-processed carefully to account for linguistic variation and noise. Class balancing techniques like class weighting during model training addressed imbalanced data issues, improving recall for underrepresented classes such as suicidal by 10%.
Okay. Well, then coming to models like random forest and logistic regression, while accurate, are difficult to explain stakeholders, particularly in sensitive domains like mental health.
That's a good argument, Srija. The project addressed this by introducing feature importance analysis and confusion matrices, For example, feature importance plots highlighted the significance of engineered features like the number of characters, making the model's decision making process transparent and credible.
Okay. Then, are there any privacy concerns arise when analyzing sensitive mental health data, including the risk of misusing findings?
Well, the simple answer is no. The project ensured all data was anonymized and excluding any personally identifiable information and strictly adhered to research protocols. Findings were presented as knowledge aids rather than diagnostic tools, aligning with ethical guidelines to respect our user privacy and ensure responsible use.
Okay, that's a good counter. Well, let's conclude this with basically, this project analyzed over 53,000 mental health statements, achieving 88% accuracy with models like random forest and logistic regression, while addressing challenges like class imbalance and interpretability through class weighing and feature important analysis. Ethical considerations such as anonymizing data and adhering to research standards ensured privacy and fairness. Feedback driven refinements strengthen the study's reliability, balancing accuracy with transparency. This work underscores the potential of machine learning and natural language processing to transform mental health diagnostics, offering a scalable and responsible framework for large scale interventions. Thank you.
Well, thank you for your time, everyone.